Hello class, welcome to this video on lesson 9.1, Pythagorean theorem and its converse. All right, so we've done Pythagorean theorem in this class plenty of times, so some of this stuff should be review, but we're going to do some new stuff in this lesson as well. So for our essential question, we'll put it up here. How do we solve problems using Pythagorean theorem and its converse? Okay, so that's our essential question. So let's look at the Pythagorean theorem, named after the Greek mathematician Pythagoras, okay? All right, so the Pythagorean theorem. So in a right triangle, so here's the Pythagorean theorem in a nutshell. We got a right triangle. It only works for right triangles, okay? You take the sum of the two legs, squares. So a squared plus b squared equals the hypotenuse. The hypotenuse is the longest side. Okay, so this is the hypotenuse, is the longest side. So that's going to be c. All right, so a squared plus b squared equals c squared. That's the Pythagorean theorem. So, and it's shown here. And a Pythagorean triple is when you take three numbers and these three numbers satisfy the Pythagorean theorem. Okay, so let's give you an example of that. So Pythagorean triple, 3, 4, 5 is a Pythagorean triple because 3 squared plus 4 squared is equal to 5 squared. Let's see if that's true. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. Is 9 plus 16 equal to 25? Yes. So this is a Pythagorean triple. And you could do this for all of these, and it works. Now, a way to generate more Pythagorean triples is to double that Pythagorean triple to get 6, 8, 10. We can also multiply by 3, triple it, and we get 9, 12, 15, and so on and so forth. We can generate multiple triples by just, multiplying it by the same number. And let's check 5, 12, and 13. So 5 squared plus 12 squared, is that 13 squared? 5 times 5, 12 times 12, 13 times 13. These add up to 169, so yes. And again, similarly, I can double this, and I can triple this. All right, and those are Pythagorean triples. All right, so let's look at an example. We've done examples like this before with a right triangle and solving the missing side. Remember, it doesn't, in a squared plus b squared equals c squared, which is a Pythagorean theorem, it doesn't matter which one's a and b. It only matters which one is c, okay? And c is always the longest side, okay? And it's always the side opposite of the right angle. So in this case, we got, okay, a squared plus b squared equals c squared. And it doesn't matter which one's a and b. So we got, 17 squared plus 7 squared equals x squared. 17 times 17, let's figure out what that is. It's 289. 7 times 7. And we add that up to get 388. Then we have to take the square root because that's the only way we can cancel out the x right there. And then we get 13 square root of 2 as my final answer. Now, let me show you how to do that. This is the part of the lesson and the chapter that I got to show you how to simplify radicals. How do we simplify that to 13 square root of 2? This is the lesson that I'm going to show you how to do that, if you haven't known how to do that at this point. All right, so let's show you how to do that. So let's say we got square root of 338. All right, what you want to do is you want to figure out numbers that go into 338. All right, so for example, 338 divided by 2 is 169. Okay, so can we divide it by 2? And the answer is yes. So 2 and 169. All right, and then we're going to circle, and we're going to keep doing this until we can't do it anymore. So what goes into 169? Well, it's 13 times 13. And again, you're using the calculator to help you with this part. If you're not very good with your multiplication facts or division, things like that, you're going to use a calculator to figure out what these numbers are. And we can't go any further because there's nothing that goes into 13, right? And so what we're going to do now is we are looking for pairs. We're looking for couples. So we got a pair of 13s there. Anyone that is a pair gets kicked out of the radical. So this pair of 13 gets kicked out of this radical. Whatever is left, which is in this case 2, stays in the radical. So this 13 is going to get kicked out. So it's now 13, and then we got the square root. Now whatever's left, that's the 2 is left over, right? So let me circle that. Is going to be there, right there too. Okay, so there you go. So 13 radical 2. Whatever's left over that is not a pair stays in. Whatever's a pair gets kicked out. If there are no pairs after doing this, then you're going to put everything inside the radical. Okay? So let's give you another example of this. So this is an example that we did, and this is why that was the answer. Let's give you another one. So let's see, square root of 60. We know that we can do 2 times 30 is 60. I'm going to circle that because I'm done with that too. Now, we know that 2 times 15 is 30. I'm going to circle that because I'm done with the 2. I can't go any further. We know that 5 times 3 is 15, and I'm going to circle that because I can't go any further. Now, do I have any pairs? The answer is yes, I do have a pair. I have a pair of 2's. So this pair of 2's gets kicked out of the radical. And I don't have anything else. So the 3 and the 5 are going to remain inside the radical. So we got the 2 on the outside that I kicked out. And it gets kicked out as 1, 2, right? Now notice that this 13 gets kicked out as 1 13, not 2 13s, okay? Square root, and then this is left over on the inside. What do you do with the numbers that are left over on the inside? Well, you just multiply them. So that's just 3 times 5, so it's just going to be 15. So it's going to be 2 square root of 15. Okay, and that's how you simplify radicals. I'm going to show you one more of that, okay, just to make sure you understand this idea. So let's do square root of 90. And so let's break that up into, we know that 9 times 10 works, right, is 90. We know that 9 is 3 times 3. And we know that 10 is 2 times 5. And there's no more, you can't go any further. So now you're looking for pairs. You got a pair of 3's, so that gets kicked out. And the 2 and the 5, that's going to stay on the inside. Then you got to multiply it back, right? So then 2 times 5 is 10. Okay, I showed you 3 examples of radicals and how to simplify them. That's what you're doing. Is it's a matter of dividing, doing a factor tree, and then kicking out the pairs. All right, so let's look at example 2. We'll use a Pythagorean triple to find the value of x. Okay, so first off, you got 14, 50, and x, right? Now, what does that look like? Well, notice that that looks like one of their Pythagorean triples that we had was one of our Pythagorean triples, if you go back here, right, is 7, 24, and 25. And notice that if I double that, that gives me 14, 48, and 50, right? So that's what this is. Notice that if I divide this by 2, I get 7, 25, and x. Okay, well then what does that have to be then? If the Pythagorean triple is 7, 24, and 25, well that means x has to be 24, right? That makes sense. Hopefully that makes sense. So then that means, but then remember that it's not actually, well, let me put this in question mark. So then this question mark has to be 24, but then we have to double it because remember all of these numbers are doubled. So we got 24 times 2 is 48. All right, and then of course we don't have to use Pythagorean triple. We can just use Pythagorean theorem, right? So we got a squared plus b squared equals c squared. But remember that c is always the longest side. And so this is the longest side. That's my c. It's always opposite of my right angle. So we got a squared plus b squared equals c squared. We could set it like that. All right, so we got 14 squared plus x squared equals c is the biggest. 50 times 50 is 2,500. Subtract 196 on both sides to get 2304. Take the square root of both sides. We get square root of 2304. And we already figured out that the square root of 2304 is 48. Okay, and you just do that on the calculator. So let me show you. Square root, let's do that over here. Equals 48, there you go. So 48 times 48 is 2304. All right, so let's look at number 3. Use the Pythagorean theorem. A summer camp is building a new ziplining course. The designer of the course wants the last zip line to start on a platform 450 meters above the ground. So there it is right there. And ends 775 meters away from the base of the platform. How long must the zip line be to meet the designer's specifications? All right, visualize and describe the situation. The base of the platform and the ground should be approximately perpendicular. We know that it should be, if we draw this situation, this is a zip line, right? And we know if we want to figure out how long the zip line must be. So let's call that x, okay? And remember that in the Pythagorean theorem, this is c because that's the longest side and it's opposite of the right angle. So we got a squared plus b squared equals c squared. Let's write down the Pythagorean theorem. All right, so we got a squared plus b squared equals c squared. C is equal to x, so we got 450 squared plus 775 squared equals x squared. And let's go ahead and add these together and multiply them. So we got 450 raised to the second power, or you could say multiply it by itself. Okay, let's figure out what that is. 202,500. And then let's add that to, okay, so we got 202,000, let's just add them together. 450 squared plus 775 squared. So 803,125. Okay, now we're going to take the square root to cancel out the squared there. And so now we got to do the square root of 803,125. Now, let's show you how to simplify this. Remember how to simplify this? Let's break it down over here. Okay, so square root 803,125. Let's see, is that divisible by 5? Let's divide that by 5. And the answer is yes. Is it divisible by 25? Because that's a big number. Okay, so I can divide that by 25. And if I do that, I get 25 and then 32,125. Can I divide this by 25? Let's see. I'd imagine that you could. Yeah, so you get 25 and 1285. Now you can't divide 1285 by 25, but you can divide it by 5. So let's do 5 and 257. Okay. Now you can't divide 257 by any other number, so I think we can stop there. So let's just circle these, because I don't think you can divide that by any number. If you can try different numbers on the calculator, and that won't work. Now notice that we got a pair of 25s, so that's good. We can kick that out of the radical, so that gets kicked out. So we got 25 on the outside of the radical, square root, and we got 5 and 257. But we got to multiply those back together. So we get 25 and then square root of 1285. Okay, and notice that that's the answer that they got there. Okay, again, you need help with the calculator to figure out what to divide by, but you should still be able to set up the tree, right? All right, and if you do this on the calculator, you get 896.17 meters. All right, so go ahead and pause the video and try the following check. Okay, so let's set up the picture. It says one of the new ramps needs to have a base that is 12 feet long. Okay, so we got a base, and it reaches a height of 1 foot. And there's our right triangle. How long should the inclined surface of the ramp be? So that's how long is that? So we got a squared plus b squared equals c squared. In this case, c is that longest side, which is opposite of the right angle. All right, so a squared plus b squared equals c squared. So we get 1 plus 12 times 12 is 144 equals c squared. And we take the square root of both sides. So we get square root of 145. Okay, now let's see if this simplifies. So we can divide this by 5, so we get 5 and 29. But notice that nothing goes into 29, right? You can't divide that by anything. And so there's no pairs that you can pull out, right? There's no pairs here. So what can we pull out? Well, we can't pull out anything. And so we're left with just square root of 5 times 29. But if we multiply that, that just gives us that answer. Okay, so therefore, you cannot simplify this anymore. This is it. So this has to be the final answer. Okay, so there are some radicals that you can't simplify, and you just leave it like that. All right, so the exact length is square root of 145 feet. This is why you have to know how to simplify radicals, because they might ask for the exact length, not a decimal, specifically like that, or if you can simplify it. All right, so now let's do the converse of the Pythagorean theorem. The converse of the Pythagorean theorem states that if a squared plus b squared is equal to c squared, right, then it must be a right triangle. It must be, okay? So we don't start off assuming that it's a right triangle. We don't know if it's a right triangle, and then we prove that it is by using the Pythagorean theorem, okay? Now, there's something called the Pythagorean inequality. And it's very important. These are the two theorems, okay? So, and let me kind of summarize that over here, okay? So, Pythagorean inequality. All right, guys. If a squared plus b squared is equal to c squared, then it must be a right triangle, right? Now, if a squared plus b squared is less than c squared, then it must be in this case, it must be, or let's say it's greater than. If it's greater than, it must be an acute triangle. And if a squared plus b squared is less than c squared, it must be an obtuse triangle. So this is how you can tell if it's a right triangle, an acute triangle, or an obtuse triangle, is by using the Pythagorean inequality. Okay, less than. Normally you think obtuse as being greater than, but it's a squared plus b squared is less than. And normally you think of acute as being smaller than. Well, it's a squared plus b squared is greater than. So it's opposite of what you would normally think of. All right, if you think about it in terms of c squared, then it'll make sense, right? So c squared is less than a squared plus b squared, then it's acute. Okay, so here's another way of looking at it. Or you can say, okay, if c squared is less than a squared plus b squared, then it's acute. If c squared is equal to, then it's right. If c squared is greater than, then it's obtuse. Okay, so you have a few different ways of looking at it. You can look at it in terms of a squared plus b squared, or you can look at it in terms of c squared on the left side. All right, so that's what those two theorems state. All right, so let's look at an example. Example 4. Classify triangles. Determine whether the points A, B, and C can be vertices of a triangle. If so, classify it as acute, right, or obtuse. Justify your answer. All right, so we got here ourselves, and actually let's, what we're gonna do is we're gonna, let's go ahead and quickly graph that, all right? So let's just make a quick graph since they don't graph it for us. Five, 6, 7, 8, 9, 10. Okay, so A is 2, 2, B is 5, 7, and C is 10, 6. All right, so is that acute, obtuse, or whatever? So we need to use the distance formula to count this, okay? So, all right, so the distance, we need to get the lengths of all three sides, right? All right, so remember the distance formula is square root x2 minus x1 squared, y2 minus y1 squared. That's the distance formula. So you subtract the coordinates of A. So you got subtract the coordinates of A and B. So 2 minus 5, or 5 minus 2, and then 2 minus 7. Subtract those right there, okay? Then you square them, and then you add them together. So we got square root. 5 minus 2 is 3. 3 times 3 is 9. 5 times 5 is 25. 9 plus 25 is 34. All right, and then we're going to subtract the coordinates of in this case, let's do BC, right? So now we got B and C. Subtract the x coordinates, subtract the y coordinates. 10 minus 5, 7 minus 6. So this is going to be negative 1. All right, let's simplify this. And 10 minus 5 is 5. 5 times 5 is 25. 1 times 1 is 1, so you get 26. And then finally, we got AC. So subtract the x coordinates, subtract the y coordinates, and then square them. 8 times 8 is 64. 4 times 4 is 16. You add them up to get square root of 80. Now let's show you how to simplify square root of 80. Remember, break it down. 2 goes into 80 40 times. 2 goes into 40 20 times. 2 goes into 10 or 20 10 times. 2 goes into 10 5 times. All right, so now we got a pair and another pair. So we got 2 pairs. So we got to kick them out. Anytime you see a pair, you kick them out of the radical. So we got here 2 and then another 2. We kicked them out as one individual 2 per pair. But since we kicked both of them out, we have to multiply them and then square root. Now, what else do we have left? Well, we only have a 5 left over, so that's going to stay on the inside, recall. Okay? Then 2 times 2 is 4, so we get 4 square root of 5. All right, and that's exactly what they got there, 4 square root of 5. Okay, so again, use the method that I taught you earlier. All right, and then of course we can use a calculator to approximate the measure of each side. So then this one is approximately 8.94. We got BC is about 5.10, and then this is about 5.83 if you did it on the calculator and got a decimal. So now we're going to we got the distance formula. Now we're going to see whether they can form a triangle. Well, based on the drawing, right, we can see that they can form a triangle because we drew it. However, they did say, can it form a triangle? It says determine whether it can form a triangle. Well, we know that the answer is going to be yes, right, because we just drew the triangle. However, how do we do it if we don't draw it? Well, remember, the triangle inequality theorem, you can use that. If they give you any 3 sides, just add the 2 shortest sides, right? The 2 shortest sides are this and this. So we got 5.10 plus 5.83, and they must be bigger than the third side. Let's see if that's true. 5.10 plus 5.83 is 10.93. And that is definitely greater than 8.94. So therefore, this must be true. They can form a triangle, which we already knew the answer to that, but it's good to check if you can't make a graph. All right, let's classify the triangle. Let's use the Pythagorean inequality. A squared plus b squared equals c squared. Remember, how do I know which one's c? C is the biggest side. This has to be c. The other 2 sides can be a and b. All right, so we got C, which is the biggest side. Remember that C is square root of 80. Where was it? Yeah, so this is C, okay? Let me just use that instead of the decimal. We got A and B. It doesn't matter which one's A, which one's B. Okay, so we got square root of 34 squared, square root of 26 squared. Now, remember that the square and square roots cancel. So we got this cancels. This cancels, this cancels. This is why we use a square root, because it's so nice, and then it cancels out when you use Pythagorean theorem. So do we get 80 is 34 plus 26? Well, 34 plus 26 is 60. Now, 80 is bigger than 60. Now, since c squared is bigger than a squared plus b squared, that means the triangle must be obtuse. if you go back to the picture, and we can see if that's the case. Let's see if that's the case. Yeah, this angle. Yeah, it looks. I guess I could see it, right? And this angle right here kind of looks like it's not quite a right angle. So it's perhaps an obtuse angle. I don't know. It's just the way I drew it. My scale is a little bit off, so that's possibly why it doesn't look exactly obtuse. But that's just because of how I drew it. All right. So go ahead and pause the video and see if you can try the problem. All right, so determine whether the points can be the vertices of a triangle and then classify as acute, right, or obtuse. All right, so let's get the lengths of all the sides. So there's a lot of work to this type of question. So let's do JK. All right, so J. All right, so let's do this JK. All right, with the square root, and then remember we're going to subtract the two sides. Subtract the x coordinates, subtract the y coordinates. All right, so we got 3 minus 1 is, so 3 minus 1, I'm just going to subtract them. Actually, let me show my work. 3 minus 1, and then 2 minus 6. Now we got 3 minus 1 is 2. 2 minus 6 is negative 4. 2 times 2 is 4. 4 times 4 is 16. So I get square root of 20. Now don't forget to break that apart. So square root of 20, that breaks into 4 times, let me do that over here. That breaks into 4 times 5. And 4 is 2 times 2. Oh, there's our pair of 2, so that gets kicked out. And then the 5 is left over. So that becomes 2 square root of 5. Okay, so that's JK. Now let's do this as a decimal. So square root of 20 is 4.47. Okay, so let's do that. 4.47. All right, so now let's JK. Let's do KL. So subtract the x coordinates, subtract the y coordinates. All right, so 5 minus 3 is 2, so we get 2 squared. 3 minus 2 is 1, so we get 1 squared. So we got 2 times 2 is 4. 4 plus 1 is 5, so square root of 5. Let's do that as a decimal. So we got 2.24-ish. All right, let's do the last one, JL. Okay, subtract the x coordinates. So 5 minus 1 is 4. 6 minus 3 is 3. We have 4 squared plus 3 squared. 4 times 4 is 16. 3 times 3 is 9. The square root of, so this becomes the square root of 25 actually, which is 5. That's a nice one. That's a nice number. All right, so can it form a triangle? Take the two shortest sides, 1, 2, and is that bigger than 5? Let's add them. That plus that is bigger than 5. Check. So yes, it can form a triangle. So yes, form a triangle. Now, what kind of triangle is it? So we're going to use Pythagorean theorem. So let's remember the biggest side here is 5, right? So we got a squared plus b squared equals c squared question mark, but we don't know if it's greater than, less than, whatever. All right, so we know that c has to be 5. We know a and b could be whichever. So let's do 4.4, or let's do the square root. The square root of 20 squared plus the square root of 5 squared is equal to 5 squared. Now the square root of 20 squared cancels out, leaves you with 20. The square root of 5 squared cancels out, leaves you with 5. 5 times 5 is 25. 20 plus 5 is 25. So this is actually equal to. So since it's equals to it, it must be a right triangle. Okay, and that takes care of the problem. All right, guys, that's going to do it for the video. Hope you found this useful and informative. And as usual, I'll see you in the next one.